Okay, properties. Individual properties are used to identify and classify different types of substances. So, properties. Just like human fingerprints, no two substances have the same sets of properties. And there are two kinds of properties we can talk about. One kind is physical properties. Physical properties can be observed, measured, and calculated. So, observations, these are things like the five senses. Measured, things like your mass, your temperature, your melting point, and calculated, things like density. And I think I have a whole bunch right here. Yep. So color, obviously, you can observe that. Phase, what do I mean by phase? I mean solid, liquid, gas, that kind of stuff. Specific heat, maybe you remember that from earth science. Density, remember that's something we can calculate, mass divided by volume. Malleability or ductility. So malleability, whoops, sorry about that. Malleability means it's bendable. So something like aluminum foil is malleable. Something like a paper clip is malleable. And speaking about paper clips, ductile means you can pull into thin wire. That's what ductile means. Conductors or insulators. Excuse me, this has to do with heat. So conductors allow heat to pass through. Those are things like metals. So if you've ever made something on a metal frying pan on the stovetop, you know that the heat from the stovetop is traveling through the metal and will be evenly distributed throughout your food. Insulators hold heat in. That's something like styrofoam. So styrofoam will hold the heat from your hot cocoa to keep it warm. Solubility, that means will it dissolve? So something like table salt will dissolve in water, so that's a physical property. Melting point, the temperature at which something melts, which is also the same as the freezing point. Same temperature, actually. Oh, look at me, same thing. Viscosity. So this has to do with thickness of a liquid. So something that's very viscous is something like lava, well, actually, I'm not an earth scientist, so maybe we'll say like corn syrup or honey is very thick. Something like water is not very viscous. So a thickness, so we're going to say resistance to flow. Okay, that's called viscosity. Magnetism. So these are all physical properties, things that we can observe, things that we can measure, and we can calculate. On the opposite side, we have chemical properties. Chemical properties is how a substance behaves or interacts. We can also say reacts in the presence of another substance or form of energy. So how something reacts on a chemical level. So if something combusts, this would be burns, explodes. So, we put gasoline in an engine of a car, it combusts. It's called a combustion engine. So that gasoline undergoes a chemical property that something like water will not. Corrosion, that's breaking down. Whoops. Tarnishing, this is something like silver. If you have real silver, like silverware that you bring out on Thanksgiving, it kind of gets this cloudy yellow color. That's called tarnish. Rusting, certain metals will rust in the presence of air, water, salts, acids. Fermentation, fermenting, that's things like turning into a beer, production of alcohol and carbon dioxide. Things that explode, giving off energy. Releasing energy and absorbing energy. So if you release energy, that's going to be something called exothermic, that's chemical property, and if you absorb, you will get colder, it's called endothermic. So an analogy to help you remember these properties is how you appear versus how you react. Okay? So those are physical and chemical properties. Physical and chemical changes, because of course, things undergo change all the time. Physical change changes the appearance, okay? So changing the size of something, ripping a piece of paper. That's not changing what paper is made out of, it just changes the size. Changing the shape of something, chopping wood, doesn't change the makeup of wood, it just changes the shape of it. Color, heating iron until it glows red. How about painting a wall? When you paint the wall, you're applying a thin layer of paint on the wall. You're not having it chemically bond and change the makeup of the wall, the drywall. Phase. Okay, so this is a tricky one, but phase changes, and there's my gross clip art of a fly and an ice cube. Phase changes don't change the formula. So ice, is water, but it's a solid. Liquid water, we'll just say this. So notice if I have a little s in parentheses, that means a solid, little l in parentheses, that means liquid. So notice how the formula didn't change at all. It's still H2O, but we had a phase change. That means it's a physical change. In a physical change, the substance's composition and chemical properties are not changed. It's still the same substance. So like we were just saying, ice is H2O solid. Sorry, this is a little bit messy. Water, H2O liquid. That's an L, cursive L. Steam is H2O gas. Sometimes you'll call it CV vapor, but usually we see gas, G. Chemical changes result in one or more different substances at the end of a chemical reaction. So here we have a chemical reaction. We've already seen this in our notes. We have hydrogen peroxide. And you see there's a reaction arrow, which means it's probably going to react with sunlight. And it's going to give off oxygen gas and water, two completely different substances. So chemical bonds have been broken, new ones have been formed, so we have a chemical reaction. The new substances formed during the reaction have different properties than your original substance. So for example, here we have sodium. Why is that out of order? I'm sorry. So sodium, here we have the metal. Okay, so this is a solid, shiny metal. It's malleable. Notice you can cut it with a knife. It reacts with water. It actually explodes with water. So messy, I'm sorry. Chlorine gas, it's yellow. Green gas. It's toxic. And table salt is solid. It's crystalline. So little crystals. And it is edible, meaning it is non-toxic. So notice that a chemical reaction can totally change the properties of what you're dealing with. Evidence of a chemical change. So if you have a temperature change, not I heated it up on the stove, but all of a sudden you mix these two chemicals and whoa, it got really hot, or whoa, it got really cold, that's called a chemical change. If you see bubbles given off, so again, I don't mean boiling water on the stove, I mean you put two chemicals together and all of a sudden bubbles are being given off. That's a chemical change. And something called a precipitate. So when you put two liquids together and all of a sudden you see a solid come out. So imagine I put two liquids in there and all of a sudden you see a red solid form at the bottom. That's called a precipitate. So any of these would be signs of a chemical change. Okay, if you've got any questions,